Hello friends, in today's question, a smooth sphere A is moving on frictionless horizontal plane with angular velocity omega and center of mass velocity v. It collides elastically and head-on with an identical sphere B at rest. Neglect friction everywhere. After the collision, their angular speeds are omega A and omega B respectively. Then we have to find out what is the relationship between omega A or omega B or omega A and omega. Okay, one of the options. So in this case, it is given that the collision is elastic. Okay, so let us write down first of all some of the key points. So first is elastic collision. And it is also given that the spheres are identical. Identical spheres. So which means they have same mass as well as radius. And third, the important one is that there is no friction. Neither between the balls, between the sphere or between the surface and the sphere. Okay, so there is no friction. So as there is no friction, you can say there is no torque acting on the spheres. You can say there is no torque acting on the spheres. Therefore, the angular momentum will be conserved. Angular momentum about center of mass is conserved. Now we can divide the entire situation into three parts. First is our before collision. For sphere A, it is given that center of mass is having velocity v. Center of mass has a velocity v and the angular velocity is omega. And for sphere B, which is given at rest, so therefore center of mass velocity will be equal to 0 and the angular velocity will be also equal to 0. Angular velocity is also equal to 0. And second part is during collision. So during collision, it is given the collision is head-on and elastic. Collision is head-on and elastic. Therefore, it is only going to affect the translative motion of the sphere. It only affects the translation motion. Of the sphere. Because of the absence of frictional force. Because of the absence of friction, that is, there is no external torque. Next is your, you can say, our after collision. During the collision also, we can say there will be conservation of linear momentum, as it is a head-on collision and it is elastic. So we can say conservation of linear momentum and because they have same mass as well as radius and collision is elastic, so the velocity of the sphere is going to change. Okay, or rather we can say the velocity of center of mass is going to interchange. Head-on collision, or rather we can say head-on collision which is elastic. Therefore, velocity of the center of mass will interchange. Velocity of center of mass will interchange. Means, and this is after collision. After collision. So velocity of the center of mass is going to interchange. So it means velocity of sphere A, velocity of center of mass for sphere A will be, let us suppose is given as VA, which will be equal to 0 now, and velocity of for sphere B, let us suppose that is given as VB, and this will be equal to the velocity of A, that is before collision. Now we come to angular momentum. So conservation of angular momentum. There is no external torque. So therefore, the angular velocity remains unchanged. Angular velocity remains unchanged. And this is your after collision. After collision. So angular velocity remains unchanged. Therefore, we can say for sphere A after collision, if its angular velocity is given as omega A, which will be equal to omega, and for sphere B, if it is angular velocity is given as omega B, and this will be equal to 0. So in conclusion, we can say that for sphere A, after collision, its velocity of center of mass, which is given VA, will be equal to 0, and angular velocity which is omega A will be equal to the initial before collision angular velocity, that is omega. And for sphere B, after collision, the velocity of center of mass, which is given as VB, will be equal to initial velocity of center of mass for A, which is given as V, and angular velocity, which is given as omega B, is equal to 0. So the only option, correct option, is C option. You can say from here option C is the correct option. C is correct. So this completes the question. Thank you.